So let us write theorem of existence and uniqueness. Now what we are going to do is we are going to take the same differential equation which is normal on some interval I. So let b0 is a function of x, dny by dx raised to n plus b1x dn minus 1y dx raised to n minus 1 and so on plus bnxy equal to rx b differential equation which is normal on I. So now what does that mean? It is normal on I means what? Means this b0 is not equal to 0 and b0, b1, bn and rx are all continuous functions on that interval on that set I. Let x0 be some number in I. Now this I is some interval. It can be infinite interval also, like in the previous examples it was 0 to infinity or whatever. So let x0 belong to I and let y0, y1 up to yn minus 1 be arbitrary real numbers. Then, so what does this theorem tell you now? Then we can find a unique solution y equal to y of x, means y is a function of x which satisfies the conditions y of x0 is, ये x0 कौन है? यहाँ है x0. y of x0 is y0. y dash of x0 is equal to y1 and so on. The nth derivative is written by bracket n minus 1, or n minus 1th derivative is written in the bracket at x0 is equal to yn minus 1. Okay, so this is the existence and uniqueness theorem for differential equation. Very important celebrity theorem. I mean, if someone asks you, have you done the course on differential equation? Then you will say, yes, I have done a course on differential equation. Do you know existence and uniqueness theorem? So the answer to this question is yes. So we know existence and uniqueness theorem. Now I want to apply this theorem and solve some problems. Okay. So when we solve a problem, you will understand what is the meaning of this particular theorem. Now what I will do is I will give you one differential equation and I will give you, suppose I give you two solutions of this differential equation. Suppose before even telling you how to solve them, I will tell you that these are the solutions of these two differential equations. And then we will try to use this particular existence and uniqueness theorem. Let me write an example. I hope you have copied this and moving the screen up. So consider differential equation y double dash plus y equal to 0. Means d2y by dx square plus y equal to 0. So this is the differential equation that I'm going to consider. Okay. Now all of us know that if you take sin x in your mind, okay, and if you find the derivative, two derivatives of sin x, the first derivative of sin x is cos x. So I'm taking y equal to sin x. So this is y dash is sin x is cos x. What is y double dash? Y double dash is minus sin x. Okay. So if I look at y double dash, it is minus sin x. And if I add y to it, who is y? Y is sin x. If I add sin x to it, I'm going to get what? I'm going to get 0. This means that this sin x function satisfies this differential equation. But the same is the story for what? The same is the story for cos x. If I take cos x, the derivative of cos x will be minus sin x. And the derivative of minus sin x will be minus cos x. So this is a double derivative. Again, I see that double derivative is minus cos x plus what is y? Y is cos x. And I see that minus cos x and cos x are again equal to 0. So this means that this differential equation that I have mentioned above is what are the two solutions for this particular differential equation? So the two solutions of this particular differential equation is obviously sin x and cos x. This is all of you know. This is a standard pendulum wala simple pendulum where you get this particular type of differential equation, and then you know that it is a oscillatory motion, and what are the functions which represent also oscillatory motions? They are sin x and cos x. That is why we get sin x and cos x. Okay, with conditions. I hope you are copying this. With conditions y of 0 is equal to 0 and y dash of 0 is equal to 1. So I'm considering a differential equation with these two initial conditions. The value of y at 0, हे समजायला एकदम अवघड नाही, एकदम सोपं आहे. ओके, इज इक्वल टू 0. म्हणजे जेव्हा मी x0 टाकणार आहे तेव्हा y ची व्हॅल्यू किती येणार आहे? ॲट दॅट टाइम y ची व्हॅल्यू किती असणार आहे? 0 असणार आहे. आणि ह्या सेकंड कंडिशनचा अर्थ सगळ्यांना कळतोय का? जेव्हा मी x0 टाकणार आहे, at that time what is the value of the derivative? The value of the derivative will be how much? The value of the derivative will be 1. This is the meaning of these two given conditions. Okay, we observe sin x and cos x are solutions of the above differential equation. Okay, I could observe that. I could understand that sin x double derivative plus sin x is 0, cos x double. But here you must ask me, sir, how will we understand? How will we observe something? So that is what we are going to learn. Once I give you a differential equation, you will be able to tell me small solutions of the differential equation. Okay. Well, for the time being, have faith in me. Let's go ahead. So sin x and cos x are solutions. So what I will do is I will let y of x be equal to, I will put constants c1 sin x plus c2 cos x. So I'm putting first solution at the first place, second solution at the second place, and I'm adding constants c1 and c2 are real numbers. Now I will find the derivative of this. What is the derivative of this? The derivative of this is C1 cos x minus C2 sin x. And just put x equal to 0 because you want everything at what? You want everything at x equal to 0. So put x equal to 0. If I put x equal to 0 in the first equation, I will get y0 is C1 sin 0 plus C2 cos 0, and second equation will give me y dash 0 is equal to C1 cos 0 plus C2 sin 0. I hope most of you must have got the hints now. What is y of 0? Y of 0 is how much? Y of 0 is 0. So this will give me 0 is equal to sin 0 is 0. So this will go away. Cos sin 0 is also 0. Cos 0 is 1. So I will get C2 into 1. And second equation I will get y dash 0. Y dash 0 is 1. So 1 is equal to C1 into 1. So this gives me that C1 is 1 and C2 is how much? 0. This is what I got. And therefore my yx becomes star becomes. Who is star? yx equal to C1. C1 का वैल्यू कितना है? C1 1 हो गया और sin x रह गया. yx equal to sin x. So this method, this type of calculations, you must have done somewhere in your 11th-12th standard. Okay. Now, what is the meaning of all this entire calculation? The meaning of all this entire calculation is that I am given a differential equation. Okay. And I'm given a point x naught in the interval. Who is x naught here? Here the role of x naught is played by 0. This is x naught. And y naught, y1 up to yn minus 1. Who are the arbitrary constants in this particular problem? In this particular problem, this is y naught, this is y1. This is the role played by y naught and y1. So let me write it in the corner. And then the theorem of existence and uniqueness tells me that you will be able to find a solution which will satisfy both these conditions. Have we found out that solution by have you found out that solution which satisfies both these conditions? I see that at the end we have the solution is sin x. Okay, does sin x satisfy both these conditions? What y of 0 is 0 था और y dash 0 कितना था? 1 था. y की जगह कौन है अभी? sin x. sin 0 0 आता है क्या? Yes. साइन का डेरिवेटिव निकालो. साइन का डेरिवेटिव कितना है? cos x. cos में 0 पुट करो. Do you get 1? Yes, cos 0 is 1. So yes, so this yx equal to sin x is the correct solution of this differential equation which satisfies these two initial conditions. So out of observations of sin x and cos x, we have removed cos x from the picture because cos x does not satisfy the conditions, right? Cos 0 थोड़ी ना 0 आता है. Cos 0 0 नहीं आता. So cos doesn't satisfy the first condition. Even cos does not satisfy the second condition. But among sin x and cos x, who satisfies the correct both the conditions is only sin x. I hope you have understood this. Find unique solution of y double dash minus y equal to 0. y of 0 is equal to 4, y dash of 0 is equal to 2. Use the fact that e raised to x and e raised to minus x are solutions of given differential equation. Okay, so I'm giving you that e raised to x and e raised to minus x are solutions of the differential equation. Now start working your calculation. Most of you have given this answer. Somebody, C1 is 3 and C2 is 1, okay, and therefore you get y of x is equal to 3 raised to x plus e raised to minus x. Okay, yes, so so let us check the, if is the answer correct. How do you check the answer is correct? Y of 0 equal to 4 आ रहा है क्या? देखो जरा एक बार सब चेक करके. Y of 0 is equal to 3 e raised to 0 plus e raised to 0. E raised to 0 तो 1 होता है, so 3 plus 1 will be 4, so this condition is correct. ओके, डेरिवेटिव अगर हम इसका निकालेंगे, सो इसका डेरिवेटिव क्या आता है? इसका डेरिवेटिव आता है सेम 3 रेस टू एक्स माइनस ई रेस टू माइनस एक्स. सो दिस मीन्स इट विल बी 3 ई रेस टू 0 माइनस ई रेस टू 0, and that is equal to 3 minus 1, which is 2. So both the conditions are satisfied, and therefore this solution is the correct solution. Yes, that's good. Exercise. Find unique solution of y double dash plus 4y equal to 0, y0 is equal to 2, y dash 0 equal to 4, given that sin 2x and cos 2x are solutions. So these two I'm giving you as homework.